Today I'm going to be covering the 2025 AMC-8 problem number 22. I'm going to be covering the brute force method, which is the one that I use in the competition. And this is a definitely viable method because it doesn't take too long. So if you have around 3 to 5 minutes left for the problem, this should be definitely a great method to use if you don't want to rack your brain thinking for a faster method. So let's get right into it. First, let's read out the problem together. A classroom has a row of 35 coat hooks. Paulina likes coats to be equally spaced so that there is the same number of empty hooks before the first coat, after the last coat, and between every coat and the next one. Suppose there is at least one coat and at least one empty hook. How many different numbers of coats can satisfy Paulina's pattern? So to solve this problem, we're going to use a very basic fundamental theorem. Basically, that theorem says that if you have a log and you chop it, let's say with two cuts, you're going to be left with three parts. Now, if you generalize this, you take this and you take n number of cuts, you'll be left with n plus 1 parts. So to use this in our problem, what we're going to say is that let's assume Paulina puts up n coats. This would mean that there are n plus 1 parts in the entirety of the coat hooks. So now we have to find all possible values of n such that n plus 1 divides 35 minus n. A fancy way of writing this is 35 minus n is 0 when mod n plus 1. So this is just a fancy way of saying n plus 1 divides 35 minus n. So basically, you just go and try all values of n. So I'll do the first couple of values for you. Let's say n equals 1. We check if 2 divides 34. Yes, n equals 2. Does 3 divide 33? Yes, n equals 3. Does 4 divide 32? Yes, n equals 4. Does 5 divide 31? No, n equals 5. Does 6 divide 30? Yes. And you can do this by yourself. Basically, you just check again if n plus 1 divides evenly 35 minus n. So if you do all the casework, you'll end up with the possible values of n. So n belongs to the set of numbers 1, 2, 3, 5, 8, 11, and 17. So if we go back to the question, it says how many different number of codes can satisfy Paulina's pattern. So if we just count the cardinality of the set, we'll get 1, 1, 2, 3, 4, 5, 6, 7. So there are 7 values of n that satisfy Paulina's pattern. And this answer would be D. So I hope you guys understood the solution. If you have any questions, drop it in the comments and I'll answer it. Also, let me know what problems you'd like me to do in the future. And be sure to subscribe so you don't miss out on those videos. Thank you.